Looks a little complicated, but you're going to get this. And there's another little tip that I'll show you in a second about which one gets skinny. One had a voltmeter on this cell, it would be reading that. This is a picture of a voltaic or galvanic cell. Looks a little complicated, but you're going to get this. This is kind of cool. So we've got two electrodes. In this case, one is copper, just good old copper atoms, and the other is zinc. And then we have solutions. And so in the copper sulfate, I've got copper 2+ ions, and then I've got sulfate ions hanging around. And then we have the zinc in a zinc sulfate. So I've got zinc 2+, and I've got the sulfate ions just hanging around. Well, believe it or not, when you set this up, electrons are going to flow from one electrode to the other, and we have to figure out which way it's going to go. So let me show you an acronym that you can recognize here, and this is called red cat and an ox, and I made this up. I know it's kind of silly, but it helps you, kind of like oil rig, helps you remember oxidation or reduction. So reduction always occurs at the cathode, because we're going to need to label those electrodes in a second. And then oxidation occurs at the anode. And there's another little tip that I'll show you in a second about which one gets skinny. One of these electrodes is going to get skinny, and one of them is going to actually get larger. So we'll get to that in a second. So first of all, what we need to do is go to our standard reduction potential table, and you can find this online or in your textbook. And I've got the copper and the zinc. Now the way we figure this out, they're always written as reduction potentials. And what you're going to do is the one that is the largest or the most positive will be the reduced, and the one that is the smallest will be oxidized. Okay, so let's calculate that. And so what I figured out, this is going to be reduced, and this is going to be oxidized. I'm going to go back to my diagram here. We've got reduction here, and we've got oxidation here. And I'm just going to write the reaction while I'm here. So for the reduction, the copper ion is going to gain electrons and actually precipitate solid copper. So that electrode is going to get larger. And then what's going to happen, the zinc ions are going to, the zinc electrode is going to actually give up electrons, provide those electrons. Okay, and so we figure out that the electrons are going to flow this way. And you will actually measure current. Okay, there's a voltmeter, right? Because the zinc wants to give up those electrons, and the copper wants to gain those electrons. So let's calculate what the voltage would be on this cell here. And so what we're going to do is take the reduction potential, which was 0.34, okay, 0.34 volts, minus the oxidation, so that was a negative 0.76 volts. So minus a negative, it's going to be a plus, and so 1.1 volts would be the potential of this cell. And if you had a voltmeter on this cell, it would be reading that. Okay, so that would be the voltage, 1.1 volts. All right, now let's go back to the ox. Okay, so the oxidation, the anode is going to get skinny. Okay, so let's label these things up. Which one was going to get skinny? Well, this one's going to actually get skinny. I'm going to draw the zinc here. It's going to be precipitate. It's going to not precipitate. Some of those zinc atoms are going to give up those electrons, and there'll be more and more zinc ion in solution. The opposite is going to happen over here at the cathode. The copper ions are actually going to precipitate to solid copper. So this electrode would like physically be growing because those ions would be coming out of solution. And so what is this? Well, this is where we have reduction. This is the cathode over here. And then this would be called the anode. Okay, so there's a galvanic cell for you. Each one's a little bit different. Where do you start? Well, you always are going to start with the reduction potential table, and that's going to help you figure out, first of all, which will be oxidized and which will be reduced.